2, 3, 4, 5, 6, 7, right? This is a unit 1, right? Isn't it?
And
1
3.
and 3.
1 and 3.
Unit 3.
Yeah.
So we only 7 now. So
Are we? No.
No, I think.
Oh, sorry, man. Yeah, there are mention
I
about
think
like
they're on the second page. That's all.
yeah. Oh my God. Yeah, I got a Red Bull now.
You probably have another deadline. Yeah.
Then is there everyone from Unit 1?
I'm checking right now. Singyan, can you confirm that your team is here? I'm going through the list. I see Yoonjae. I see Jeon.
Yeah.
So that's 2 people. Yeah, and I guess the professor member cannot join us today. Okay. That's great.
And
Yeah, go ahead.
no, I was trying to ask like Hyosun and Yangsan, if you don't mind, can you turn on your camera as well? And Yuki, I understand, but yeah, can you make a sound to make sure if you are here?
Yeah, I'm here.
Cool. Because she's in Toronto, so it's very early morning, so she's understandable.
Yeah.
That's great.
Yeah.
Sorry.
No, it's fine.
It's all right.
I closed it because I was like eating. Sorry, it's just for
okay.
Youngmin, can you confirm that your team is here? I actually only see you and Yeonjun.
Yes, we are missing Kiwon. I think he's on his way home.
Okay. And Daeyoung is here, right? Kil Daeyoung.
Yeah, Daeyoung is here.
Yeah.
Okay, great. That's great. So
who's gonna go first?
since we're unit
Volunteer.
1, should we go first?
Yeah. Go ahead. Just one team. Team A or Team 1, whatever you want.
Yeah.
I mean, the choice is kind of already made because one team is missing a member that's on his way home. But
Okay.
I mean, so is it okay, Simyeon? Would you like to do the honors?
Yeah. Yoonjae will presentation, so I think he should.
Okay, Yoonjae, are you there?
And just to give info to the Unit 3. So in our case, Team Shinchon will do the first, and then in the end, Team LJ do the first at the latest.
Okay.
Sound great. Team Shinchon. Wow.
All right. I think if your team
Are we just starting from the team presentation, or is the unit master can probably briefly introduce what the unit is about?
Right.
Maybe just for 2 minutes. Yeah, that would be great.
Right. Well, unfortunately, I haven't prepared the slides for this, but maybe for the final
that's
crit, I
fine,
can.
yeah.
Well, for the 2-minute intro, I would say we are Unit 1. We've studied Mathematica in the first week, where we learned to perform various tasks with it, including machine learning, image transition using pre-trained cycle-GAN neural network, and etc. So here we are exploring various opportunities where we can utilize Mathematica to our advantage and explore the aspects of architecture where we can see, for instance, see the past overlap with the present, or speculate how the urban organization can be considered differently when it's transitioned or juxtaposed with certain images or any type of scenario. So yeah, I'm excited myself to see what they've prepared, and yeah, let's watch it together today. That's it for me.
See, we're excited.
Okay.
Okay. Should I go or
Yeah.
enter? Okay. Okay. Yeah. So okay. Unit 3 is like we started from the C# script from in Grasshopper, and we had a look into the agent-based system and within the attractor. And so we tried to at the beginning we were thinking about the investigating about the movement of some social figures. So each team brought into their script into their own site, and then they looked into the which can be. I mean, they just investigated. They investigated what can we see from the agent's movement, and then their what is their like interaction between the agent, attractor, and repellent at the same time. So yeah, I mean that's all for me from now on. Yeah.
Thank you.
Thank you.
Yunjae, whenever you're ready.
Yeah, I think I'm ready. Just a few seconds, please.
Sure.
Technical difficulties always happening on online presentations.
Could you guys hear me?
Yes.
Yes.
Yeah. So hello, we are Team A of the Unit 1 session.
Just a second, Yunjae. I think the slide is zoomed in. We can only see the top left corner of it, the quarter.
Okay.
If you have the PDF file, I suggest switching to the Adobe Acrobat or Adobe
PDF Reader would be best. Yeah.
Yeah, I think web browser doesn't work too well.
Because we have the video session, so video thing, so that's why we are using the web version.
It's okay if you switch in between, I think, you know.
Oh.
So you can go with the Adobe Reader and then stop for a moment and bring up the browser. I think that's totally fine.
But is video not working in Adobe PDF?
But it seems like you publish it as an EPUB, right? Seems like, or did you? Is
You
this
should
PDF
publish
file
as-
or?
Yeah, you should publish as interactive PDF.
Yeah,
you can
tried
insert the
that, but
hyperlink.
Okay, then I'll start with the PDF and then change to the web.
Yeah, it's okay. It's okay if you switch in between.
Yeah,
Because
thank you.
consider this as a practice run for the final presentation on Friday. So we would expect a smoother presentation on Friday. So you can take this as a learning curve, I guess.
Yeah.
So it's okay?
Yeah.
Yeah.
Looks perfect.
Okay, thank you. So hello, we are Team A of the Unit 1 session. Our project is named as The Tsunami. We are Jae Chong and Chongyun Wan and Seungyun Park and Junjae Kwak. Let me begin. For the long time from the past, Han River, which is passing through the Seoul, has lots of meaning to Korean people. With the Han River, people enjoy their daily life and use to spend their vacation and time. However, recently, the situation has changed and the Han River was overflowing and flooding the Seoul city. We know we need to talk about this issue. Will the Seoul and the Han River be forever like this? So we define these issues as the tsunami of the Han River. So let me change into the other one. So the tsunami project aims to visualize the moment when the Han River is overflowing to the end of the Seoul. Sorry for that. This diagram shows what we're gonna do. We're gonna make it as 2D and 3D model, visualizing the moment of tsunami. So we have two steps for the goal. First step is in-paint and pixel sorting on the satellite map. The intent is to fill the empty spot by machine learning. After detecting boundary of the river, we expand it and erase it so that the Mathematica redefine boundaries of the river. Sorting pixels of the overflowing image to figure out the scenes when the Han River is overflowing. Referring to the Dr. Jae-Hong Lee's pieces of art, we thought the pixel sorting is the best way to show what we imagine the dynamic of it. To define the various sides of the to define the various sides of the Han River, we restyle and the Han River with multiple functions in Mathematica. The function that we used image restyle, edge detecting, and clustering, and etc. So we do style transfer too. The second step is voluming, make it as a volume, and visualizing the scenes when the Han River is floating to the end of the Seoul in 3 dimensions. To represent how the water is waving, we're gonna extract the features from the waving video, applying those features to our images. With the pixels of the first step, we're expecting that the pixels will waving over the Seoul. The Seoul will be made with Rhino models. With this project, with this project, we wanted to propose that the new perspective on the Han River above conventional perception of it and its relationship with urban context. Thank you.
All right, thank you. I think we kind of missed the previous slide. Could you show us what that was?
Sorry. So this shows the feature detection of the water and the wave of the sea. So we're gonna use those features to the dynamic of the flooding in 2-dimensional the map and if possible to the 3-dimensional the model.
Okay, so would anyone like to
I
start?
have a question. So that that Han River flooding image, did you Photoshop it, or did you?
This one we use the, I'm sorry for the explaining, but we use the in-paint function there. So we erase the part of the image and let the Mathematica fill it by machine learning. So this is actually the new boundary of the Han River by Mathematica.
Great. Is this different from it? Was it relatively quick and easy? Was it different from Photoshop? So I think that aspect I'm more interested in. I think I appreciate your presentation and the narrative, but I think I'm more interested in how you use Mathematica to generate different, in your case, there are different images, and what algorithm were you using? How did you use it? Because now you are using a kind of a plan. So you say a lot of like, I will do this, we will do this, but I think you only have not more than 2 days left. And I think it should be about what you did, what you studied, what you tried. And with this short workshop, we don't really need, in my opinion at least, we don't really need any like grand architectural urban project. We really need to see the potential of the tools and how you learned it and what you produced it. And I think these 4 images, I think it's stunning video. It's really interesting. And I want to know why this is different from Photoshop and how this is different. If you compare, how did you set this up? I get your concept, then just really go for it. Maybe you erode a lot of different cities to create similar imagery. I don't know. That's my suggestion.
Yeah, thank you for your
Can
suggestion.
you, well, I think it would be great if you can explain a little bit more about what kind of potential of the mathematical tool you use, and how you used what you used to produce this image, and what you have learned, and what's the potential, etc. Because this is not your unit tutorial, so including me, I think a lot of people actually with that kind of a brief explanation, we can't really follow in a way. I can roughly understand what's been done, but if you can be a little bit more kind to explain, that would be, because we want to learn as well. That'd be great.
Yeah, I think you almost want to do it more like Juheng's tutorial. You know, he was teaching how literally he was doing this, like line by line, how he was changing different parameters. Now, if you can just build that, like explain us through how you managed to produce this set of image, for example, as an example from Hangang University, but you can maybe go to different positions of Hangang University, and just like really series of images, literally like what Juan was producing, his artworks. That's like really interesting aspect of his lectures. And if you can just mimic that aspect, it's already a very good exercise. I think this video here was very underestimated. I almost want to see how, like zooming in to a lot of different like positions where I want to see that like positions of some boundaries where you meet this eroded beach of Hangang. I think I almost want to see like a lot of details here, and it's beautiful. This is beautiful, and I want to see, almost want to see a full animation, high resolution, and with a lot of different positions of Hangang in different cities. I don't know. You might not have to do a lot of videos about this, but this is a very valuable output. And if you can just really explicitly produce this, I think it's a very good outcome out of this workshop. And we don't really need anything else like a grand scenario. The erosion idea of Hangang is already good enough as a concept, and just dive in and just erode this city. That would be my suggestion.
Yeah. So actually, to put a little bit something about these 4 images, actually the most interesting picture isn't here. Actually, the most interesting thing is the field, the whole Han River with the urban context.
Mm-hmm.
So actually, it's the opposite of this way of Mathematica, because I mean, because we made the city, the urban context, as Han River, but the opposite was a much more actually interesting. But we kind of extracted because it's a little bit out of our the narrative. But I mean, as you said, I think the with more like close zoomed in view, I think this seems like more interesting and to really good to see how the Mathematica could produce another way of the urban context. Yeah. And for the Jane's or what Jane said, actually I think it depends on persons, but for my personal experience, Mathematica is very good for, I think it's a very simple language because for my personal experience, I think we needed to code a lot of lines of code to produce something. But with Mathematica, just one simple line could actually produce something very beautiful and very functional, I think. And even this in-paint function is so simple so that everyone can use it like really.
It is really beautiful. And if it's so simple, then we want to see a lot of different variations out of it.
Yeah, I totally agree with what Sumin is saying, and I'm starting to see it more and more. I think you should take her opinion full on board and turn this into a video project. I think you've shown me some of the Max Cooper, was it? His videos. So they're very architectural and give us a lot to think about, and they're open-ended questions. So maybe I would highly recommend that you take on Sumin's advice on board with the team.
Maybe you can also just oppositely turn the hangang into city. So like eroding the water into city blocks, for example. There are lots of variations you can play with, I think. That's really exciting.
Yeah.
I mean, it doesn't need to go be that complicated. I mean, yeah, like deep, that complicated. But yeah, like at least like there's a lot of things like Sumin said. There's lots of things you can play with inside of the Mathematica. Yeah, I mean, you can combine some like a different simple line of the code, and then after that you can see there's some also the other more interesting result, I guess.
Yeah, I'm also curious how Juhan was managing to boost or increase the pixels. I remember in his lecture, he was mentioning about something to make little lower resolution images into higher resolution. I think that's also something you can think about, because I don't know how much you can zoom in and what was the input image resolution, but whether that will help you to zoom in or zoom out or flip it or eroding, filling the Han River with soul and occupy. I don't know. There are lots of pixels you can play with.
I think there is a website to increase resolution. I think that website also using AI system. I don't know how it's behind it, but normally people use it. And can I ask something?
Yeah.
I mean, there are 4 sequential picture there, right? So is this showing the gradually flooding in Han River area? This is a kind of, like a chronological things from 1 to 4. Am I right?
Seems like.
Yeah. You can say that.
I don't know what you guys trying to do, but it's quite interesting to me. I mean, like this kind of river system is basically man-made, like a artificial bank.
Yeah.
Kind of, river system, but this image is gradually generate, like a.
Daesung, I think your sound is breaking.
Sorry? My sound is not working?
No, go on. Yeah. No, go on. It's all right now.
It was a bit breaking.
Oh, okay.
No, it's fine. It's fine. Yeah.
Okay. That's why I'm a bit interesting. I mean, if you generate those kind of natural, like a river show, I mean, this kind of like techniques very impressive, because I mean, the city of Seoul, there are lots of projects to manage those kind of artificial riverside into the, like how gonna say, it's organic shape of, you know what I mean? It's a natural kind of. I mean, they want to make a natural kind of system. I mean,
Yeah,
that's why
definitely. It can be a design tool, isn't it?
yeah, I don't know, but I mean, it's my own, like interpretation of your work. So, in the sense, it's quite interesting, but I'm not quite sure about the kind of logic behind it. I mean, what kind of like a data set you gave to the machine, and what kind of result they turn out. I mean, that is there's a question, but to me, it's really interesting in the sense. So
Yeah,
it's just my own opinion. I don't know.
That's interesting point. For example, what makes that curvature, whether if you run it again, does it give you the same curvature? So is it like parametric that you can control this curvature, for example? Like you can, like in this way, you can actually take it as a design tool to design the shore of the river. I think that's also an interesting take on all of these things.
Is this
the
series of the images that you guys wanted to show the awareness to show the impact of Han River to people, or is this actually sort of the image that's showing the data, which means almost well, similar to like a flood map?
To answer to you guys' questions, actually, we couldn't really, manipulate a parameter with this function, and that means I think it's something Mathematica generate, and something, yeah, it's not something based on some very specific data or something.
Yeah, so you can basically just analyze what we are asking is just to understand the black box behind algorithm of Mathematica. We are not asking you to, if it's not available to change any parameters there, we are not asking you to control it or something. What we are asking is to, as you are on behalf of us learning this, explain to us, you know what I mean? Like you master this algorithm and tell us how you use it to design the city or design a video.
So basically, we want to see some potential of the Mathematica, actually.
Yeah, that's my point.
Yeah.
Yeah. And I mean, on Friday, when you guys do the final presentation, I want to finish your presentation by mentioning what would be the potential of this tool, and then this could be possible. Maybe what about this and that? So we want to hear that on Friday.
Yeah, if you are saying it's just one line, it was so easy, and I don't know how the second image and third image was created. Can you create something in between? What was that parameter? At least there must have been like at least one parameter that you're changing. And what is that result? And what happens if you change tweak the background color of your input image? Does it change your result? Like all these are interesting things. So basically like do some play and experiment as if you are working with Photoshop, different if you open Photoshop, you will run a lot of different menus and functions and try this and try that and create a lot of different images. Basically, that's it. So you try different things and really master at least like 1 or 2 functions and explain us how you learned it, what was your trial and experiment.
Okay, but I'm sorry. Maybe I'm sorry, but my English is a little bit short. But
it's totally fine.
What about other teammates?
Yeah, please.
Help him.
Hello. Can I interrupt?
Yeah, of course.
Sure.
Yeah. Yeah. Hello, I'm Jin Zhang, one of the team member of Yunje. Yeah, we understand what the tutor is saying, and on Friday final presentation with your critics opinions. Thank you for your opinions. With your suggestion, we are gonna focus on what we can do with the Mathematica tool with the more simple way, and we are gonna produce more images or more examples with the with more functions of the Mathematica. So, yes.
Oh, looking forward.
Yep,
Yeah.
thank you.
We
We
will make up for that. Okay.
Yeah, actually we use a lot of functions and then we manipulate the parameters as well. So the final result was these 4 pictures, and then that on the final presentation we will present more examples or more practices.
Yeah, processes, how you got yeah,
practices.
exactly.
Processes. Yeah.
Oh, we are very curious about that.
Yeah. Okay, we understood it. Thank you.
Thank you. Almost
Thank you.
like give us tutorials on Friday.
No, no.
No, like almost take it like a tutorial, algorithm tutorial.
No, I'm suggesting, I mean, not to demonstrate, like how to use Mathematica things. I mean, try to lead the result and then on what kind of value you found it from your thing. That is a more important thing to us. So you know what I mean. And then also, I mean, there are so many images you can generate from the Mathematica platform, but but you have to control it anyway. You have to examine. Otherwise, it's no meaning. I mean, people easily compare with the Photoshop techniques. So I mean, that is the main point, right?
Yes.
Okay. Right.
Okay. Can we finish? Can we wrap up?
Do you have any more questions or comments?
Other questions from the students? Okay. Thank you. Thank you very much. Thank you for listening our project. Thank you.
Thank you.
Thank you.
Thank you.
So yeah, shall we move on to our team Shinchon? And in this team, there was some problem with the PDF. So I'm going to share the screen, and they're going to present. Just a moment. Okay. All right.
Thank you for the PDF file. So yeah, I'm ready to start the presentation. Hello everyone. We are in Unit 3, Team A, and yeah, our nickname is Shincheon, and our project name is Yeonjae Road, which is the name of the main street in Shincheon. And we are in Tak Oh, Seungyeon Oh, and Jihyun Lee, and I am Hyo-sun, speaking for the team. So yeah, can I move to the next page, please? So Sinchon is where Yonsei University is, and actually other than that, Sinchon is one of the most busy and lively neighborhood in Seoul, having 4 university campus nearby. The area is always full of young people. Can we next, please? Yonsei is the main street in Sinchon, stretched from Yonsei University to Sinchon Station. Along the Yonsei Road, there is a 2-lane car street in the middle, and there are small alleys from the main street where restaurants are densely located. In Sinchon, it's crowded in the main streets and in the alleys. Here on the diagram, as you can see, there are 2 big axes crossing Sinchon, and the from Yonsei University, that's Yonsei-ro, has car streets, and the purple one is a totally pedestrianized street. With the scheme of revitalizing Sinchon area, local government is aiming to return more main streets to pedestrians. Next, please. Therefore, they got a special traffic policy. During weekdays, only public buses can enter to Yonsei-ro. However, on the weekends, they are blocking entry of any cars into Yonsei-ro. On the weekends, Yonsei-ro is full of street events, as you can see at the images at the bottom. Next, please. However, due to its policy, bus routes differ on weekdays and weekends. It is confusing local people to take a bus travel in the neighborhood. We are tackling this issue, thinking that is it possible to keep Yonsei-ro pedestrian-oriented, but without a change of bus routes every week? So the current bus system here is during the weekdays, buses can enter with the speed limit of 30 kilometers per hour. That's the current situation. And next, please. So as a solution for our question, we brought the topic of autonomous bus. So driverless car, that sounded like a future technology, but it's not far away from us. And we are supposing that when self-driving car is introduced in our daily life, I think transportation system is the first one thing to be changed. So we are thinking that kind of our daily life will come true within 5 or 10 years. So we are supposing a scenario that the bus system, transportation system, is replaced with the autonomous buses. So next, please. So there are some concepts on our scenario. The first these concepts we are suggesting are based on what the commonly talked among mechanics, among researchers. So our first concept is without a driver's seat, the bus gets more compact. And the second concept is driving is, of course, accurate with a computer. Therefore, with these 2 concepts, car lane can be narrower, and then it can be curveless, and then it as a result return more space to pedestrians. So with the current dimension, bus width should be 2.5 meter, and lane is 3.25 meter, and we are expecting that it can be 2 meter width of car and 2.5 meter width of car street. Next, please. And the third concept is so we are working on the working based on condition in Sinchon that with this specific situation that it is a straight street, the street shape is straight and then straightforward, and there are only buses going without any other individual cars. So based on this condition, we're thinking that with the computational driving, buses will there will be transmission of real-time information between buses. Therefore, their driving will be more accurate, and we are now challenging kind of impossible situation at the moment, but might be possible in the near future. Oh, I'm sorry, just like I was disturbed by the message. And then, so with this concept, we are challenging the idea that it might be even with computational driving, it might be even possible to change the number of the car lanes on one street. Then in our life now, it will cause a problem like a bottleneck problem, but we are suggesting that it will not happen with technology. So yeah, bus lanes are interchangeable. Yeah, and that's our third concept. Next, please. Oh, and I'm sorry, one more thing in the previous page. I'm sorry. Can we go back to, yeah, here, so we are also moving, there is in the middle of the image, there's a current center line, and also we are pushing this a little bit to the one side to give more space for street events. Next, please. So this is a simulation of that computational driving. Here it is happening. So it reached at the bottleneck, and by the system, one stops, slows down, and yeah, they made it away. So it is possible. Next, please. So it is our so from unit 3, on the first week we learned about C# scripting, and then with the script we had, we were making use of it to simulate our idea. And this is our input. First, there are more elements on our script. First is agent, and the second is attraction. And there is we're calling it as a repeller. So there are agents representing pedestrians, and the street events on the streets are working as a attracting agent. And buses are repelling agents, blocking in their way, because agents will tend to want to move away when bus is coming to them. So it is reflecting that. Next, please. So there is a working with the script. So there is a basic this setting to make use of this script. The thing we figured out is that at every frame, for each frame, we set agent speed as 1 meter. That the average speed of pedestrian is 4 kilo per hour, which is equivalent to 1 meter per second. That when the agent is going 1 meter at every frame in the grasshopper, we thought that that unit as 1 frame is equal to 1 second in a real life. That with a comparison, we got a bus speed as well. So our input in comparison will be 5 to 8, which represents 25 kilo per hour to 30 kilo per hour. And then also there is other input such as pulse duration is how long agent is interacting with the attractor or repeller. That if we are setting pulse duration at 60 with this time unit system, it represents that agent is staying at the street event for 60 seconds or 1 minute. So that's our setting. I will pass this on to one of my other teammates. So next page, please. Hello, Intak. Could you please?
Okay. Hi, I'm Intak, and we try to find the right figures for gravity through the first simulation. And first of all, the simulations were divided into weekend and weekdays, and into commuting hours and other normal hours during the week. Because of the large number of people on weekends, the people same is set at 500 or less during the week. The meaning of value represented by gravity is the degree of interest in event. The meaning of values represented by range is the scale of event. At first, when two events were held over the weekend, the value of gravity was divided into 6, 8, and 10. You can see people gathering around the event center in range when gravity is 6. In this page, gravity is 6, and these 6 images are same gravity, but we change a range to 2 to 20. Yes, so we can see this range 8. In range 8, people are yes, I'm sorry. People are gathering at 8 and 10 and 20. Next page, next page. And this page is gravity 8. At this same range 8 and 10, 20 is people are gathering too. Yes, and next. Yes, this is
Sorry,
same.
but I think you have to point which spot is the event spot so that
yes.
people can understand what you're talking about.
Okay.
Yeah, I'm lost already.
I'm sorry. This is Yonsero, and event is there are 2 events. Here you can see another color. This is one event, and the other event is here. So people are gathering at 8, 10, 20. The 20 is very bigger, but when buses come, yeah?
네.
저한테 하시는 말씀이신가요?
No, no, go ahead, go ahead.
예, 그래서, 예, so 8 and 10, 20 range is, we can find value as a gravity, as a 2 event. So, next page, please. Next page인가? Yeah. This is simulation. So, okay, so we sorry, wait, please. From then on, the gravity value was set to 8, and event was added to the simulation. Next, please. I'm sorry. Is it previous? Yes. The 잠시만요. From then on, gravity is 8, we set, and we added another event to here, and here. This point and this point is original point of event, and we suggest another 2 points in here. So when event range is 8 and 10 and 20, there is very suitable for autonomous bus. So first we set 3 range to 8 and 10, 20. Next, please. And then we simulate another situation. This is weekday afternoon. So there are 200 people in here. So gravity is 8, same, and these points are new event. And in here, result frame is 1 second. So if range is 8, the bus move here to here, the time is 98 seconds. But when event range is 20, it's more time in here. So we can choose, we choose 8 and 10, 20 range, but in this situation, we accept range 20. Next page, please. And then this is weekday rush hour, and gravity is same 8, and we added 7 events. Here, 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 and original point here. So in this situation, range 8 and 10, 12, but bus traffic is not good, same 12, but new 10 range. Yes, because it's 100. Yes, bigger than range 8. So next page, please. So finally, in conclusion, we found that when the range value is 8, the largest event can be opened without interfering with vehicle traffic. Later, we would like to find a suitable location for the event with the previously decided gravity 8 and range 8. Yes, it's done. Yes, done. Thank you. And sorry. Yes, it's finished.
Okay.
Okay.
Is this the end of your presentation?
Yeah, I think so.
I think so.
Yeah.
Okay,
Seems
first
like,
of all,
yeah.
Okay.
I have 2 comments. One is in general, what you explained, I really didn't get it. So maybe it's better you summarize with 1 sentence.
May I interrupt if I can help?
Sure.
Our goal is actually with our aim of the project, we want to have street events without interrupting bus system too much, and the result, counting the number of frames, it is representing the time it took in the grasshopper the bus to arrive to the end from the start. So if the number of the frame is higher, it represents it took slower. And for our script, you were looking for the right value or right input, like to make use of the script. So Intel was like doing a comparison to find the right range value.
I think that's more than one sentence.
Oh, sorry.
So am I right? Is it just about the optimization of, like a number of event location? You guys trying to find optimal number of event spot, right?
Yes.
Am I right? And according to the bus traffic, right?
Yes.
I mean, you say 87 frame means 87 seconds, something like that. I'm not sure, but the frame is definitely time count, right?
Yeah.
Okay, so finally you guys said and then event range 8, that is the best result, right? Isn't it? You say that, right?
Yes.
So why is that?
Why
do you evaluate it? And then, like, I mean, I understand your logic, but there are so many questions behind there. You know what I mean?
Do you want to answer in talk? Why 8 is the best?
Yeah, that's interesting, but there are so many questions still remain. That's the point.
Yeah, I think hi, this is Uje. I'm just interrupting here, but I'm not sure if I can help. But I think the reason why they choose event range 8 as the optimal solution was because its frame number is the smallest of all. I think that's primarily the reason. But here I actually have one more question to add. So what does it exactly mean to have a smallest number of the frame?
In mind, we might not be looking for the smallest. Looking for the best balance. It is of course good if the bus arrives the faster without any interruption. But we're looking for balance between bus and street pedestrians. That, yeah. Is this an answer?
So yeah, I mean, if I can help, like, so since the bus is stopping because of the people's human pedestrians congestion, so they wanted to look for the fastest, how can I say that, fastest bus, not route is always going to be the same. So the fastest situation when the event is happening, like in several locations. So they found that as far as I understand, like they found that there are 7 events, and the size of the event, like 8. They found that it's the fastest for the first route, I guess. Am I right?
All right. I think for this later part, it is matter of making it clearer and explaining with more like less technical terms. So if you are saying less frame as Uje was explaining, I now kind of understand that lesser frame means it's faster.
Yes, I guess.
You want to change that terms into something that we can generally understand. To say it's faster.
Right.
Like which one is short?
Right. So I actually have one more suggestion. So I know it sounds like I'm asking way too much, but I was just wondering if all those 6 slides here on this screen, are they just a result of a single iteration of the analysis? Or do you guys do some sort of like multiple iterations per each parameter sets? So you can basically, oh, you did that. Okay, so it is not a single iteration capturing a specific moment, but rather you did multiple iterations for the same set of parameters for instance, you did more than one iteration of event range 8, and then with the other parameters like number event 3, gravity numbers to 8, and a post direction duration as a 180, and then you tested multiple times with the same set of parameters, and then you kind of average it, right? I mean, yeah, the reason why I'm asking this is, because of the nature of wonder of individual agents in the system. So they basically based upon random function, right?
Yes.
So it could happen lots of different variations. If you repeat the same iteration over and over again, even though every single parameters of those iterations stays the same, but your end result might be different from each other. Do you know what I mean?
I was like a little digesting the question, like confused with if I got it right, but like if I could answer, we took out like lots of parts of our analysis because it was too many iterations.
Mm-hmm.
But the fixed values at the left side is the value we fixed with after iterations. So with iteration, we got to know what this parameter means in our real life. So we like fixed everything and changed the gravity, and then we figured out, oh, it's just like how interesting this event is. So like it is the content of the event. So let's fix this with just 8, and it's fine. Like it worked that way. Is it the answer?
Right. I mean, I think I'm basically questioning that approach. So how can you for sure that there's a certain relationship between this parameter, and then if you increase this parameter like by 1 or something, and then how the frame, the total frame will drop or increase. So if you want to be more scientific about this matter, then you basically have to repeat the same iteration over and over again until you find comfortable zone where you can say that yes, this is it. This obviously has some sort of relationship between this parameter and then overall frame numbers, etc. But I'm not insisting that you guys have to do it right now. But I'm just pointing out that might be your weakness in your argument.
Yeah, if I may, I appreciate that suggestion, and I think definitely you guys need to like train yourself more with explaining these simulations and make this into a good evidence of what you're arguing. But I think there is a fundamental issues in your project now. I think really just going back, like eliminating all this simulation part. I think I really appreciate your simulation, your rigor, and like a lot of diagrams and tests. I appreciate that. But I think you kind of misunderstood the whole point of this introduction of this self-driving car. The self-driving car is not for the sake of the self-driving aspect. It's more about how you can introduce a certain mobile system that can coexist with human and with public programs. So you actually don't have to, you should get rid of the traditional notion of road. Now you are still creating this like bottleneck road. I think that you should really eliminate that. And you should look at all the public space that is not built area. And you should rearrange that over time. And sometimes within the day, they will become roads. Sometimes they will become pedestrian place. They will become restaurants. They can occupy different programs over different time zone according to the best efficient ways to occupy these spaces. So the point of using this self-driving car, they don't have to be self-driving. They can be driven by human. But the point of using this is that you can actually rearrange this area with the best efficient way that they can coexist. So you don't have to close the road for bus in the weekends. You can still have that, but maybe they will find the best, better route, maybe going around to go around with to avoid some public programs, you know. So yeah, I appreciate you found the 7 is a good number to occupy, but I think you should really look at the entire Sinchon area more as your site, and I don't know what is your goal. Are you finding the route for bus, or are you finding your goal is to find the best number of events in this area? I think you want to set up something like a clear goal, but I think fundamentally it should be some kind of scenario that best occupies these different agencies together in a more harmonious way. Yeah, instead of redesigning the bottlenecked road for smaller buses, I think that is not the point of integrating these references.
So I mean, I think if I was to say this one help, I think Team A, I think they did get the point of introducing the self-driving bus, and it's not the bottleneck that they showed. I think the diagram was a bit misleading. I think if I understood it correctly of the Team A project, I think they were trying to find the numbers and the location of the potential events area along the Yeonsei-ro, while they can introduce the buses that coexist with the pedestrians and the events on the weekends, because currently the weekends the whole road is pedestrian only, right? 효산, it's 내가 얘기한 게 맞. I think you guys have to make it clear that what you are trying to do.
Sorry, in the meantime, could you please scroll up to the beginning of the presentation? By the way, I think this is a great project.
More? Is there more?
Yes, please. Yeah, I missed the first part of the presentation, so I just wanted to see. Right. All right. I think you guys can go on. So Hyo-san, I think we're still waiting for your answer.
About saying yes or no for professor's explanation, or may I ask the question again?
Whose
yeah,
question?
answer. No. Your question actually.
My question. So like so on our slide, maybe like if you go next, or I'm sorry. I'm sorry.
What I was I actually interrupted your conversation when June asked you a question that her explanation of the project was correct or not. Sorry about that. Do you know what I mean?
Yeah, was my, maybe, sorry, I should have not said anything.
Okay, hold on. The point is, point is trying to find optimal number of the event space.
Yeah.
So,
and also, that is your point, right?
Yeah, and then I would like to clarify a little bit more that so we were looking for like a balance And about the bottleneck, you're not creating a
I understand it. I understand it.
Yeah, bottleneck is not unconventional bottleneck. To minimize, so we're looking for the balance between minimize car street and maximize pedestrian. But it might be a little conservative way compared to covering all over Sinchon. It might be conservative, but we approach with the scenario. It is like a future in 5 and 10 years, like bus system first, like without all other cars, bus system first change, and then I know.
I understand it, but you guys have to introduce or digest or explain about what that exactly means of collision. I mean, you know, your script or you're using the like logic, you know, there are point and the numbers or I don't know the scale they collide each other, right? So how can you understand it that as a value, you know, what that means? You know, without that knowledge, I mean, you know, I understand what you're trying to do, but I mean, it must be like convinced to the audience. Otherwise, is you know, that's why I say. I mean, there are lots of questions remains behind. That means, you know, I understand what they're trying to do, but you know, like I'm scratching my head. There are lots of questions. You know, that's things. But that's why I'm a bit, you know, like unclear about that. You know.
I mean, I think the part of the reason of the confusion may come from the fact that your you know presentation is a little bit too lengthy, so you might want to consolidate it to you know like you know within 10 pages, and then just rather than explaining the minor tiny things in your diagrams, you can just focus on the big idea, and you know try to explain what's the ultimate goal, and then what was the strategy to achieve that sort of things. I mean, it doesn't really help to explaining, you know, lots of different numbers, parameters, how you set those parameters, and what the difference, there's a slight difference in parameter value means. That was kind of, you know, boring. Although all those diagrams and the analysis are fantastic, super. Do you know what I mean? So I'm just here to help you to present better and then convey your idea more efficiently.
Yeah, I think all the questions from the jury is because of, I think, is a clarification of your presentation, I guess. So, I mean, maybe, yeah, for the Friday's presentation, please try to point it out. What is the important figure, and then why is that? And then I mean, the other things, and of course, it's all your work. You can show them, but yeah, you don't need to mention all of the simulations. Yeah, details. Yeah. Just
but I do really believe this is a really good project, fantastic project. Good job.
Yeah. All of a sudden, good
job. Seriously, seriously.
Yeah. No, I really appreciate you guys' work because it in a way they only sort of understood and then made the simulation work just 2 days ago. Yeah, so it was a great sort of a work and a great jump up to today. But I think it still sounds like you guys still didn't quite digest what you guys are doing. Yeah, you're kind of like, yeah, it's working, and then we produce this, and then this is what it means. Maybe just up to that point, but now I think you really have to digest, and then you have to really question yourselves what these means and what's the potential, what's probably the problem again, and then to lead to the final sort of presentation on Friday. Yeah, good luck.
Yeah, so if I sorry about that, but if I add one more thing, when you present your idea, you don't really have to explain the technical aspect of your project. to the audience. You can just focus on the big picture idea, and then what's the strategy that you use to achieve that goal. And then if you have extra questions about your technologies, and then what those the parameters means, then you can explain this is for what blah 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 extra. You know what I mean?
Yeah.
I had one more.
Yep.
It's really great pointed out. Yeah. So, thank you, Jay.
So
I think there is some you missed some the beauty of this agent system. So actually, the beauty of the agent system is kind of the bottom up process. That is, this system does not disregard all the small entities, but at the same time, it combines all these small entities into just one big figure. So which means you can get from this small scale aspect. At the same time, you can also see this very big picture, the whole picture. So I think if you find some relationship between these two factors, it would be more the right project, I think.
Okay.
all right.
Cool.
Cool.
Is there any more comments from jury or students, or students from the other units or the other teams? Whichever.
If I may go, since I didn't really say anything, I would just like to commend you for the work that you've done. I think the technical drawings and the scripting it looks amazing. Like all of the juries have pointed out, maybe there needs to be a bit of how you compose the presentation might need a bit of work, but aside from that, I think you guys have done great work.
Good.
Thank you. So if there is no more comments, maybe we can move on. Shall we?
Yep.
Yep.
Great.
Very much.
Thank you.
Thank you very much.
Thank you. I think the first team from the unit 1 probably didn't explain enough of the technical things, and then probably the first team from the unit 3 has explained it too much. I think they have to mix a little bit.
Yeah.
And the student with us says, "What do you want?" Yeah.
No, Mathematica is just one line. I mean, they call
Yeah.
the code,
Okay.
they call the
Yeah.
function. That's it.
Okay.
No, there are no need to
Oh, that's
explain
why.
it. I mean,
yeah,
it's
that's
more
why there's
about
nothing that you.
concept. That's why.
Okay. Fair enough.
Shall we move on to the unit 1's next team, or do you want to have a just short break before you move on? What do you want? Juries?
Short break?
Yeah,
Short break?
I need one more pint of coffee.
Okay, let's have a 5 minutes break. I mean, 7 minutes.
5 minutes break.
No, let's say 7 minutes break since it's 23. So let's start from 30.
So, yeah.
Okay.
Cool.
All right. See you later.
Cool. Thanks.